Hello everyone, welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to do experiment tracking using DVC and then Dagshub, right? So Dagshub is a very nice platform where people build data science project, right? So in case you want to build a data science project and you want to do MLOps, Dagshub gives you all the things that you need, right? Very nice. So in case you don't have an account, you can just go back to dagshub.com and then you can just sign up. Okay, so in today's wonderful project, you'll be trying to do a very simple project. So we're going to use AI machine learning. We're picking this bank marketing dataset, and our task in this dataset is to classify or predict if a client will subscribe to a term deposit, right? That is going to be our task. So let's see what we're doing. So we'll be trying to build a simple project, then use the different tools that DVC, Dagshub, and then Dagshub logger to track the different experiments we'll be generating, right? And then I'm going to see the result. So our basic workflow, as you already know, is that in case you are working with any data science project or any data science project, you are not only working with your code, but you're also working with data, which is going to generate models and different assets. We use Git to track our software and put it on GitHub, as you already know. And we use DVC, data version control, to track our data, our model, and our asset, and put it into your different cloud systems. Or you can use FastDS to do both of them and put it on Dagshub. So in today's workflow, we're using a very simple workflow, which is the basic workflow in case you're working with DVC and then Dagshub, right? Very simple. So we have some like 5 different steps. So step 1, we will be using Git and then DVC to initialize the project that you are working on, the directory. Then we can just check the status of it, right? Perfect. So we use Git to track our software, we use DVC to track our model and our data, right? So in case you want to track your data and your model, you just tell Git that, okay, DVC data version control, I want to add this particular file. These are the files I want to track. So DVC add the particular CSV file, right? Or data file, then DVC add model. So you're using DVC to track your data and then your model, right? And then the moment you do that, it's going to generate a sample file. So .dvc for any particular file that you added for the data and for the model, and then .git ignore, which is going to have instructions to tell Git that, oh, Git, do not track these particular file. Don't track my data, don't track my model. DVC will do that for me. That is step 2. Step 3, we are now going to tell Git that, okay, Git, we want to add some things to you. So we'll be adding the DVC file and the Git ignore via Git, and then also be adding our main Python source code, right? And then our metrics and our YAML file, right? So these things are generated in case you are using MLflow or Dagshub logger, right? So this is very useful for experiment tracking, and the name must be Metrics.csv and Params.yml. Perfect. So the moment you just do this, it's going to be placed in the staging area. Then just go to git commit, which is step 4, to put it inside the commit area. Then just go to git push to push it to Dagshub, right? That is a basic workflow. For your data, now after pushing it to Dagshub, you need to also push your data to somewhere. So you can store it on Dagshub, or you can store some configurations on Dagshub that's going to point to where your actual data is, either in the cloud or in your drive or in your bucket, or as well as on Dagshub. So you do that with step 4. Step 5, which is DVC push. Then you push, it's going to push your data, your models to Dagshub. Then from there, you can do your ML experiment tracking. Right, that is the basic understanding. So for the ML experiment tracking, it's very simple. The most important thing you need is you need your metrics and your Params.yml file. Then you're going to push them to Dagshub. Then you can do all the various things. So you can use MLflow, you can use Dagshub logger. So let's see how to use this wonderful workflow. So this is going to be a workflow. So I'll provide a link to this particular place so that I can have access to it, right? You can use it for any project. Okay, so let's go back and see how to do that. So if I come back, we'll be using the old project we did, which is the ML project from the previous tutorial. And then we will just go back to our workspace. So this is my workspace. As you can see, inside my workspace, so I go back here and I check out, I have my files here, right? So we have my banking dataset from UCI machine learning, this particular dataset. You click on this, then you can download it, right? So I've already downloaded it and I've encoded it to save us time. Perfect. And then we have our process folder where we committing our process files, and we also have our script.py and our train.py. This is going to be our main file, right? So let's open it in Sublime. So I'll go back again to my workspace and open Sublime. So here, come back again to Sublime. I'm going to open that particular place. Perfect. So this is the place, right? So the code is already there to make it simple for us. So I'll be explaining it to make it easy. So we're going to import all the packages we need. So we'll be importing pandas and a scikit-learn. So we'll be using two different models, logistic regression and decision tree. And then you will import our train test split to split our dataset and then the different metrics. Then for the other utils, we need DagsHub. So DagsHub, you can use in this place. You can also use MLflow. So you can also import MLflow. Right. Same thing. This is for ML experiment tracking. Right. So you can use MLflow the same way. DagsHub also can also be used for ML experiment tracking. So you can also use this one here. Right. So perfect. So both of them can be used. You can use either MLflow or DagsHub. So let's use DagsHub. So in case you don't have DagsHub, the package itself, just go back to your terminal, then just go with pip install DagsHub. Right, that is how to install it on your system. Make it bigger. That's how to install it on your system. Right. So we're using DagsHub to help us track our experiments. Perfect. Then we are just importing joblib to serialize our model, and then these things are just to beautify. Right. So this rich is going to help us beautify it, right? So I have a whole tutorial on rich. You can check it out. We can check Python engineers tutorial or one little coders tutorial on it. Okay. So the first thing is that we're going to load our dataset. So a simple function to load our dataset using pandas, and another function to pick our dataset that we have loaded, and a particular label, right? The class label, and the size, and then the output, right? Then you're going to create our features and our labels. So we'll be dropping the label, and then we'll be keeping the label as my y. You can also use this particular approach to help you do that. Then you split our data set, right? We train test split. You can also change the test size in this particular place in case you want here. Perfect. So that you can alternate the sizes. Then after that, you will be saving our train data and our test data, right? This is very important. So the reason we are saving this one is that you need to have, in case you have processed your data, right, very well, you can use maybe a feature store like Feast, or let's say a feature store itself, or ByteDance, to store your features, right, so that you can retrieve it in case you are doing your machine learning project. Perfect. So that's why we are saving these ones, right? So we know what we used. So in that case, you also need to get some metadata about the dataset we use, right? So we'll be using pandas to log all the columns for the features, right? And the same thing, we'll be storing them inside the CSV file, right? So you can actually put this one straight away into your process file, but let's keep it outside our process file. Then we also be keeping the labels, right? So we know what labels we used and what features we used. Then going to be returning them back. Perfect. Then the next step is that we building a pipeline, or we building a model. So we have two functions. One to build the pipeline, right? So this is a very simple function. So it takes in an estimator. It can be any ML algorithm, your S features, your Y labels, and then your transformer, because it's a pipeline. Then you're going to generate your pipeline, right, which consists of your transformers and your model, right? You can also build a simple model to do the same thing, right? But I prefer to go with the pipeline because we want to be scaling our data set. Okay. Then we will also create another function to evaluate our model, right? So we pass in the pipeline generated, and then we pass in our testing data to generate our accuracy, our F1 score, and we can also do the recall, right? Any of them as you wish, right? So this is just precision. Then it's very important to store these things inside the dictionary. Perfect. So that is the most important function. Now we'll be running our functions. So this is going to be the function. So first of all, step 1, we will load our data set. Step 2, we will split in our data set. Step 3, we will build our model. And then step 4, we will evaluate our model. So let's run it and see whether it's working. Everything is working as expected. So I'll save this one and I'll run it. Come back again to my workspace, right? So as you can see, so this is my workspace. So I'm going to be running it. So I'm going to leave this one so that you see the result of what you have done. So if I come back and I check it out, you have my train.py file, which is where all the code is. And I can just go with Python 3, then train.py. So this is going to pick that particular one and process it for us, giving us our result. And as you can see, it was able to generate our result, right? So if I go back here, this is the initial one. If I go back and I just do 3 again, you can see that now, if you compare this one and this one, inside our process folder, there was nothing here. But now we have our S test, Y test data. We also have our features, and we also have our target, right? Very nice. Now we also need to create some two important files, which is these files, right? Our metrics and our YAML file, right? This is very important for our ML tracking because we need the metrics.csv and a YAML file, right? Params.yml file. So how do we do that? So we can use Dagshub logger or ML flow. So let's go back to our code and modify it since it's working. Come back again, and this is the code, right? To save us time. So in case you don't have Dagshub, you can just install it with this, import it perfectly, which I've already imported, right? So let's put it at the top of our code. So I'll copy it and put it here, which is this one here, right? Perfect. And then let's go back again and check this code. So Dagshub gives you the option of using Dagshub logger. So there will be a tutorial on only Dagshub logger to make our work easy. Then we're going to update that using the context manager, right? So Dagshub logger.Dagshub logger as logger. Then we will be, first of all, we will save our data model, the particular model that you're using. So I'm going to be saving the model, right? So this pipe is coming from the pipe here, which was generated here. Perfect. And you're saving it here, right? You're using decision tree, that's why it's called DT, which is what we are using here. Perfect. And then we will be logging the parameters that we use. We'll be logging the model and the different params from it, right? So we'll be using this particular option to get that particular model, the name, and then this one is going to be used to log the various parameters of it, right? So this is from Dagshub, right? Logger.log hyperparameters. Number two, you also need to log the metrics, right? So we just evaluate our model. Then we are going to use log_metrics to get the metrics that are coming from our dictionary that we had here. This particular one here, right? Perfect. So that is the basic understanding. So that's the basic thing. You just import, you dump your model, you log them as you wish, then you log the metrics also. So let's save it and run it again. I'll come back again. So let's run it again. Which run it again. Take some time for it to run. It's going to give us our result. So in case you have any question or contribution, you can put inside the comment section below, right? So it's generating the data set, generating training data, generating metadata. It's giving us an error here because no such file models power has been found. So the reason it's giving us this particular error is that we don't have the directory called models here. So let's create that particular directory. So mkdir models. That is it, right? Now let's run it again. So run it again, second time. So this is it. So if I check it out, we have our models folder. So that is where the model is going to be stored. Our data folder where our project data is. And see that the metrics has already been generated, right? Very fast. I need to overwrite it, don't worry. So that now it has given us our result. Perfect, right? So our model had an accuracy of 0.88, F1 score 0.89, the higher the better. And then the precision was also good, right? So that is the basic understanding, right? Very good. So we have gotten our metrics. If I come back here and I check it out again, we have our metrics.csv file, we have our params.csv file. So let's see what is on this file. So I'll come back again, check it back, and let's see. So if I go back to my metrics, we have the name of the model, right, which was this one, and then the various metrics that we had, right, together with the timestamp, which is very useful. Then if I go back to the params.yml file, we have the model name, right, and we have the various parameters, right, for the particular pipeline. So we had the decision tree parameters, and we have the scalar for the transformer parameters. Perfect. So this is very important. These two files, the metrics and the params.yml, is very important for the ML tracking. So since you have done with it, I'll come back again to my workspace and you try and follow this workflow, right? So be following this workflow. So first then you're going to check the status of it. We have already initialized it. We're going to check the status and we're going to add this one, right? That is going to be the first code. So let's check it out. So the same place we have, so DVC status, going to check DVC status. You can also use FastDS to help you do the same thing, but let's follow the DVC format, then later on you follow FastDS. So getting pipeline up to date. Now let's go with Git status, and you can see that we have some things that we need to track, right? So among these things we need to track, we need to tell DVC that, okay, these data files, all my data files, I don't want you to track. Git, don't track it. DVC is going to do that. And then the metrics and the params, Git is going to track it, right? Together with the target.csv, right? So let's go back again and see how to do that. So now if I come back again, let's bring it here so that I see what I have. So you want to let DVC handle the data and then the model. So the simplest way is just go with DVC add, right, and then use this particular format. So I prefer this format because this is going to go to your data folder, which is everything inside the data folder, right, and then everything inside the models folder, and then save them, right? That's why I use this one. So this is the step number 2, right? So this is, it's very useful function, so you can always use it, right, to keep track of your models and your CSV data. So it's tracking it, as you can see. Perfect. Now the next thing that we need to be able to also tell Git that, okay, Git, so by default you want to do that, it's going to generate this particular command, right? So these are the things that we have to commit, right? So all of these things, right? So if I go back, to my workspace, so let's go with 3. You can see that now it has created this DVC file to track our data itself for the train test plates, right? Nothing was done, but for these ones, for the PKL file too, it was created, right? But I also need to do the same thing for the process data. So let's go back again and do the same thing here. So the same thing we did, but this time we're doing it for the process data, right? Which is going to be process. So we are doing it for the process too, right? So that we have those ones stored. It's going to generate the same thing for these ones, right? So let's go back again, right? Check it now, so that has generated it for them, right? Perfect. So that is step number 2, right? You have done this. So it is going to, you see that it has created this DVC file. As you can see, all these particular DVC file have been created, and there is also a get ignore file which has been created, right? Now we need to be able to commit those things out. So that is going to be step number 3, right? So this particular command, so it's going to be this option. So git, let's go back again to here, which is the same command that was here. So you can just copy these ones as you wish, but I prefer to go with a simple approach. So git add, and what I want to add is that I want to add the data, right, slash all the .dvc file. So .d*.dvc, right, all of these DVC files, right? So this particular command, and then .get ignore file. So .get ignore. So everything with get ignore, right? All of them. Perfect. Now do the same thing for the process folder. Right, and then this data slash, right, so that we keep track of it. Perfect. So now we are done with it, right? So the next step is I'll just go with Git Status to check what you have done. So now we have all our Git file tracked, right? All the DVC has been tracked. Perfect. And then for the models too has been tracked, right? We also need to so the model has been tracked. Perfect. So let's see what again that we need to track. We also need to do the same thing for the models folder. So what was not tracked was the model, so we have to also track that one. So go back again, do the same thing we did, but this time we're tracking the model. So inside our model folder, the model, then we need to track our, you can just do this option, .dvc, right? Perfect. So that is it. So if I go back again, Git Status, perfect. So the model has been tracked, right? The model and the Git ignores have been tracked. Perfect. So what we need, what now is left is this one. So these ones, Git will be storing them. So that's going to be step number, still under step number 3. So we need to commit the metrics and the code. Still on Git. So Git add, we're going to add the, what we are adding the CSV and the train. So let's go with the train.py file. Then also want to add the Metrics.csv file, and then the params. This is very important, that's YAML file, right? And you can also add a target because this one is simple, and then the feature because these ones are smaller, right? Perfect. So you are done with it, right? So you have added these ones. The reason I'm adding these ones there is like they are very small. That's why I'm adding it there, right? But the actual model and the actual data is somewhere else. You can even keep these ones there also. So let's go with Git Status now to see what you have. So everything has been tracked. Let's do the README. Of course, let's add the Git Add README. Yeah, okay, perfect. So Git Status, everything has been tracked. Perfect. Now we are finished with this particular option here. Perfect. So everything is inside the staging area. Now next thing you need to commit. So git commit. And let's call it as experiment. This one, let's call it as a added experiment. Let's call it added ML experiment, which is version 1 for decision tree, right? This is for decision tree. Run it. Perfect. Now let's put git push. So this is now going to push it to Dagshub for us. I'm going to ask for my Dagshub credential. So JCharisTech, then your password, right? Perfect. So that's pushed it there already, right? Perfect. Now let's check and see if it is there. So I come back again. Here's a project. As you can see, there's nothing here, but if I refresh it, you're going to see the result. So now it is there, right? Don't worry about the time. So now added ML experiment, everything is there, right? And then all of these things are there, right? The CSV, the metrics file, and then the params file, right? Now let's also push the data itself. So now I'll be pushing the data. So I'll come back here and I'll do that one here. So it's going to be my DVC status. Everything is up to date. Then you can just push it. Perfect. Which is going to be, so pipeline is up to date. So DVC push origin. Because we have already configured the remote, it's automatically going to go straight away to Dagshub. I'm going to ask for my password. And now it's pushing it there. So 6 files have been pushed, right? Perfect. Now if I come back again, if I refresh it, then now it's going to push that particular code here, right? Inside my data folder. Perfect, right? So that's push it there. Now the moment you add this particular metrics file, metrics.csv, let me make it bigger so that I can see. Apologies for it being small. The moment you add the metrics.csv and then the params.csv, if the moment you just add those particular 2 files, this is very important, this and this, with this particular name, don't change the name, it's automatically going to detect it, right? That is the smartness of Dagshub. It automatically detect the experiment. The moment you have the metrics.csv file and then the params.csv file, whether from Dagshub logger or from MLflow, it's going to detect it, right? Perfect. And then one nice thing about Dagshub is that it's going to show you your data, your models, right? The name of the models if you have notebooks. The DVC is that in case you want to filter all the DVC, the one that DVC is tracking, if I click on this, all the things that DVC is tracking is going to be shown here, right? So these are all the things that DVC is tracking, which is our models and our data. If I click on the Git, it's going to show me all the things that Git is tracking, which is very, very cool, right? So in case you want to know what your DVC is tracking, just click on this, or the DVC is filtered, Git, or the Git is tracked. And then if I come down to the pipeline, you can see that now we have our Git, the metrics, the one that Git is tracking, is giving it a different name, right? The params, and it's going to give you all the metrics on it, right? All the scores on it, which is a very nice, cool feature. You can actually expand this one out, right? By going with this. Perfect. So this is the data pipeline that we have. You can make it very nice and very cool as you wish. So now you can just see the metrics. So this is going to be our metrics. We have our params. So we have our metrics, our params. We have the data set that we have. We have our train data set. I can click on this. It's going to show me where this data has been stored, right? Perfect. And then the same thing for the processed and then the rest, right? Very cool. And this is going to be our pipeline, our model. Okay, so that is something very cool with that. Perfect. That's for the pipeline. Now we have one experiment, right? If I come back here and I check it, because I have my metrics file and my params file, I have one experiment there, which is this particular experiment here. Perfect, right? So this is one experiment that we have, right? It's going to tell me the number of seconds and the name of it, automatically generate a name, and this is a very nice feature, right? So we have the different comments, the name, you can also click on the different parameters. These are the parameters. So this is the particular parameter I'm using. We have all the different parameters there, right? Perfect. You can also filter these particular labels, right? You can actually assign a label to this by clicking on this and assign a label. So let's give it a label. So let's call this one as decision tree. So decision tree. So decision tree, right? You can give it something like that. It's going to create a label for this particular one, right? Perfect. And then you also have the source code, you have the get and different parameters. You can also filter these things, right, by clicking on this here, and you can also filter the particular column, right, the different stuff. You can also go back to the columns here and filter them. I click on the columns. It's going to show me which of the columns I want to show here, right? So as you can see from here, there are a lot of columns that we are seeing. I can go straight, but in case you want to limit the columns, you can click on the columns, and then you can select the column that you want, right? If I come down here, we have the unselected columns, we have the selected metrics, and the ones you want to keep. You can just drag them, right? So these ones are not being pinned. You can just click on this to pin it. It's going to pin it here, right? As you can see, you can also drag them and arrange them as you wish, which is very cool, right? You can also do some very cool stuff. Okay, so let's unpin it. So there are a lot of things you can do with them, right? Very, very nice features. Okay, you can even search for a particular column. So let's go back and close it. This is for one experiment, and with just one experiment you can't do a lot of things, right? So let's add another experiment. So I'll come back again to my workspace, which is here. I'm going to modify my trained file. So the first one was decision tree. Let's change this one from decision tree to logistic regression. So this is going to be 2. So let's put the logistic regression classifier, the same thing, right? And I'm going to change this one from this to LR for logistic regression. So where I'm changing the model, right? And then I'm changing the name of the model, right? Everything is going to be the same thing, right? Let's call it as LR. Everything is going to remain the same, right? Because I've already imported logistic regression from above. So let's run it again. So I'll save it, come back again, and I'm going to run it. So let's run our experiment. So Python. I'm going to run it and I'll follow the same steps. So it's going to take some time for it to run. So in case you have any question or contribution, you can also put inside the comment section below and let me know your comments about it, right? As you can see, it's working on it. I'm going to print out all the results. Voila. And as you can see, the accuracy is very high, right? Perfect. So that is it. Now it is going to also generate the same file. So we're going to repeat the same code we did above, the same steps. This is where we can also use FastDS to help you with your tasks, right? In case you don't want to repeat it. But so we just go with the same command, this command, this command, and this command, right? Just 4 different commands. So let's do it again. So come back again to this place. Now run it. So let's go back. First one, get status to see the changes. Perfect. See that there are some changes there, right? Git is telling us all of these things are still the same. So I can easily push these ones there. Let's go back again and check it out. So DVC status. Nothing changed, right? For the pipeline, nothing changed. The only thing that changed was my train.py and my metrics file, right? So because nothing changed, I just want to push these ones there, right? So I can just push these 3 files there. You can do that simply using this option. But there was also a change in the model too. So these are the things we want to change. So let's go back again with this. So Git. So let's go back again and go with Git Add. Before we add them, let's also do DVC add these particular stuff. We want to do them again because we have made some changes within them. We're going to generate our one. We need to generate one for this one, right? So that is the code here. So we'll just use the same command to help us with that. So I'll copy this and I'll run it again. So that is one nice thing about DVC. So let's paste. Perfect. It has committed them. Then we need to be able to move on and then move on straight away with Git Add for this one. So we need to add these ones to it. So let's come back again. So Git. We need to add the metrics, the CSV file, and the Params.csv file. Perfect. So Git status. Everything has been tracked perfectly well, right? So only the README, which did not change, right? Now let's push it. So Git commit. So ML experiment 2. Let's call this one as logistic regression. So logistic regression. can't spell logistic. Logistic regression, right? Perfect. And now we can just put git push. So if I push it to my credentials, perfect. So that's pushed there. Now if I come back again, let's go DVC. We have them again. So let's do back. It's still going to check, push them perfectly there, as you already know. Then DVC push, right, to push them back. So now if I come back again, I check here, right? So this is 1, as you can see. If I go back again and I check now, it's going to be 2 because now we have 2 different experiments there. That's the nice thing about Dagshub. It's automatically going to detect it, right? So which is trying to version control your different models and your metrics, right? So we have experiment 2 because we added 2 there. Perfect, right? You can see that this one was added, and you can just go back again and click on the experiment. So once you have 2 experiments, there are a lot of things you can do with it, right? So mostly make it 2 or 3 because experiment, you keep on trying to get the best model. So I click on this experiment, and I'm going to see the different experiment that we have. This has been quite a long tutorial. My apologies for how it is. Trying to simplify it to make it simple. Perfect. And as you can see from here, right? So you can see that now we have the first one just 12 minutes ago. We're going to see the second one also coming, right? The second one is also going to come. There, see that we have the first one, right, 2 minutes ago, and this one was 12 minutes ago. Wow. So now I can just give that one a new label. So let's call this one as let's give it a name. Give it a new name. So let's call this as logistic regression, or let's call this logistic, like log reg, something like that. Yeah, to make it simple. Perfect. So we have one for dysentery and one for logistic regression classifier, right? Perfect. And you can see that these ones, the params were not shown, but don't worry about it. Right, so we have the train test split. All of them are there working perfectly well, right? So let's see whether we committed the params. Did we commit the params? So let's go back and check it. Yeah, we did commit the params. Okay, perfect. So now if I go back again, since we have 2 now, we can compare, right? Once you have 2, you can compare. You can just click on select that one, and then when you select, you can see the difference. You can also go with select this one, right? And now I can just go with the compare. So if I click on the compare, we can compare the different models, which is very easy, right? So just generating the metrics gives you the option of comparing the various models, and this is how the comparison looks like. So we have comparing 2 experiments. It's going to give you the commit ID and then time just created and all the various things there. So if I check it out, see that now it's giving us the various metrics. So we have the one for the dysentery and the one for the logistic regression, right? Together with the time just created, which is a very nice thing, right? So this is very useful, so that in case you have different ML experiments, you can compare them, you can get the author time. So in case you are doing a project from different teams, right? Each team will commit to this particular place, and you can see the different teams, right? They are working and their commit history, and you can also compare the different params, right? So don't worry, it's going to populate them perfectly, some of them. And then see that we have the dysentery classifier, right? Perfect. Now if I come back again to here, see that we have all of these things there, right? For the logistic regression and for the dysentery. That is one. That's not all. You can come down here and see the plot, which is a very nice plot. So with the plot, you can see the different stuff here, right? And you can also check the different metrics, right? So this is for the metrics. So let's pick, there's nothing here, let's pick one again. So I want to check the F1 score. If I check the F1 score, now it's going to show it here, right, for that particular model that we have, right? Very nice. And you can actually save it, which is a very nice feature, right? You can save it and use it for your presentations. Wow, there's a lot of features out of the box. Okay, then you can also come down here. So let's save it. So let's save this one. Okay, you can also compare the different metrics down here, right? So this is a very nice plot too, based on the chart. You can check the train accuracy for the model. So this is going to be the train accuracy. So we have the one for the tender pair, right? And we have the cherry elbow. If you click on it, you can see it very well. You can also scale it, or you can also hide one. In case I want to hide this one, I can just click on this, and now we only have the tender, but which is the decision tree, right? Very nice. So this is for the accuracy. You can do the same thing for the F1. So although if you check this ones out from here, you can see that it's almost the same because the logic regression is higher, and then the decision tree is 88%, and then logic regression is 91. But let's check the F1 score. If you check the F1 score, it's also the same thing, right? That means that we will be picking, in this case, we will pick the logic regression. If you check the precision, the logic regression is way, which is this one, right? The green one is way more precise, right? Very nice. So there is some very cool stuff you can also do. You can actually save these ones as you wish. So there are a lot of things you can do with this wonderful option. So the simple workflow is that you need to always make sure that you have these two files, right? You have your metrics and then your params. So if you have your metrics and your params, you just push it, and once you push it, you are going to be able to compare different models, right? And you're going to automatically detect it. So that is how to do machine learning project tracking using Dagshub and then DVC. So I'll leave the code around the cheat sheet so I can just follow. After generating your code, just go with this option: step number 2, step number 3, step number 4, step number 5, and then you are done. So thank you for watching, and see you in the next session. Right? So apart from that, you can also come back and you can just only select one, right? In case you want more about it, you can just go back and then select only one of them to see more details about it, right? Which is a very nice feature. Wow, the Dagshub team have done so much wonderful stuff. So in case you only want to select one of them, right, or you just click on this, the name, or click on this, any of them. If I click on this, it's going to automatically give me all details about it, right? So this is it. So the time just finished, the commit history, the source code, the label. You can also add another label. So let's say you can add another label, like any other label that you want to add to it. You can take off one and call this one the best model, the various details, and then you can see the various metrics, right? So the params, you can search for the params in case I want to get for the particular param, let's say solver. So solver, and now we have the solver, the particular solver I use for this particular model. Also check for the metrics. So let's say I want to get the F1 score. Something went wrong, but don't worry, they will fix it, right? So you can actually check for something very nice, right? So thank you for watching the tutorial, and see you in the next session. So you can see that even with that one particular, we can see all the various metrics of it, right? Together with the different stuff. So thank you for watching. See you another time. Stay blessed. Bye.